Today we're going to start taking a look at rational expressions. We've got a couple of days that we're going to work on these, so this is day one of that. The first item on the list to accomplish today is to remind you what domain is. A domain is the set of all input values allowed for your expression. In particular, with the kind of expressions we're working with that you want to remember is that the denominator cannot equal 0. So any value that might make your denominator, or not might, but that does make your denominator zero out, equal 0, that's not a valid value. So we'll start first with a couple of, with one simple expression so you can see what I'm referencing. It talks about excluded values. Excluded values would mean values that make the denominator equal to 0. Now, you might be able to look at that, depending on what the expression is in the denominator, and actually just tell me what the value is. In fact, I'm sure some of you probably could for this one. Do you know what value would make this denominator 0? 4. Yeah, so it is 4. For those of you who are like, how'd they get 4? Or if it were one that you didn't necessarily just look at and be able to tell, what we do is we set the denominator equal to 0, and we solve. Okay, so we're going to go through the steps on this one just so you can have it in your notes too as you're looking back. You can move either the 3W or the 12. I'm going to move the 3W just because it'll make it positive when I do. So 12 equals 3W, and divided by 3, there's that 4 that you mentioned just a moment ago. So W equals 4 would be an excluded value. Now, similarly, if I were asked the question of what's the domain then, the domain would be all real numbers. This doesn't ask in this question, but I want to make a reference to it anyway. All real numbers where it's not 4. In other words, every number is usable and valid except for the number for 4. The answer to this question is the one that's already boxed in. This is sort of just a note at the bottom on how this ties into the fact that we talked about domain and what that means over there. One slide up. All right, so I'd like for you to recall a fact about factors. We did factors for fractions. So we should recall a fact about fractions is what I meant to say. We talked about this back when we did fractions with just numerical values, just numbers, back in sections 1.3 and 1.4. If you multiply the top and the bottom by a value, or if you were to divide the top and the bottom by a value, we have the exact same factored expression as before, right? Not factored expression, fraction expression as before. So we're okay to multiply the top and the bottom, we're okay to divide the top and the bottom. It doesn't actually change the value of the expression at all. So we're going to talk about simplifying expressions now that have not just numbers in them, but they actually have variables in them. So on the first one, problem number 2, what you'll notice is that it's already in factored form. Right? I already have everything in the little parentheses. They all are nice and neatly sort of factored for me. And what we want to do is we want to reduce it, based on what we just said above, right, by anything that they have in common from the top to the bottom. That includes numbers, so we don't want to forget about the 8 and the 48 in front, but it also includes entire factored pieces. So I can't cancel terms. Like if I had a plus 2 at the end and plus 2, there's no canceling out plus 2s. That's not a factor, okay? That's a term. So I cannot do that, but I'm looking for pieces that are in factored form that I can cancel. 3u plus 8 would be the one here that cancels. Okay, so that's the factored piece. I still need to look back at the 8 and the 48 though. So what do 8 and 48 both divide by? They both divide by 8. So if I were to divide each of them by 8, on the top I'd end up with a 1. You can either write it or you don't necessarily have to. I also have the u plus 3. On the bottom I still have the 6, and I have the u minus 5. You can leave it like this. You do not have to write the 1. I'm going to write down another expression. So you could leave it like that, and that would be acceptable, or you could actually just leave it as u plus 3 on top, even without the parentheses, because there's nothing it's being multiplied by now. but there's no reason to multiply the 6 through the denominator, so we can leave it in factored form, and that's actually what this is here. Right? We're going to leave it in factored form. So either of those versions would be factored form answers for the problem.
Question. If
Yes.
it asked you to solve, would you just set the top and the bottom to 0?
Yes, but it would only say solve if it were an equation and it already had an equal 0 in it.
Yeah.
And this one doesn't. And it wouldn't set the top and the bottom equal to 0. We'll get to that, I promise. It looks a little different than what you're describing, but you have the right idea. Yes, Armani.
So all we're doing is canceling it out and then simplifying it?
Right. We're reducing, right? We're reducing common factors and simplifying what we can.
Okay.
Exactly. Now, the first one, problem number 2 here, was nice in some sense because it was already factored, right? Number 3 is not already factored. We have to do that work ourselves. So we're kind of combining what we did with factoring in the last 2 sections, right, with what we did with reducing factors inside of fractions back in sections 1, 3, and 1, 4. So this is a combination kind of section. So on the first one, we always would want to look for common factors. So in the numerator, 15u squared and negative 10u, what do they have in common? 5 and u, exactly. So we're going to pull out a 5u. So if I pull out 5u from 15u squared, what would I be left with? 3u, and then from the 10, I would have minus 2. Great. How about that denominator? What do they have in common? A 5 and a u, right? And if I pull that out, what am I left with? U minus 5. So this time, the part in parentheses, whatever actually like visibly currently in my parentheses, they don't match. So I can't cancel those. But the parts before them in the front do have pieces that match. In fact, they completely match, don't they? That doesn't always happen. Didn't happen on the last one, but it did here. So those would reduce, and I'd be left with 3u minus 2 over u minus 5.
Why can we cancel out like the 2 5u's, but then like on the first one we did, we can, or like you said something like a bit
Yeah.
at the end.
It's the way it's combined. The 5u's at the front of this one are being multiplied by what's next. The example that I was giving was something where it was being added with what's there. It's all about it being in factored form, and factored form indicates that you've got multiplication of terms.
Okay.
Yes. Good clarification. Okay. You ready for another one?
Yes.
Okay. This one looks simpler in the fact that there's not as many numbers and as much sort of going on. But the factoring is different. I don't have anything in common on y squared and 16 in the top. I don't. But it's one of our special factored forms. What is it?
Difference in squares.
It's a difference of squares. Yeah, you were trying to think of it, I know. Yeah, it's a difference of squares. So, again, if it helps you to see it, write it out. This is y squared and this is 4 squared. Not 4 squared like the game, but 4 squared. So, how will the numerator factor?
Y plus 4, Y minus 4.
Right, y plus 4 and y minus 4. And the denominator will be still y plus 4. But, what do you see?
No parentheses.
There are no parentheses, but what else do you see? Yeah, this entire denominator is exactly the same as one of the sets of parentheses in the numerator. The whole thing. Not just the plus 4. I couldn't do it if it just said plus 4. Like, that would not be okay. But the entire thing cancels. All of it. So I'm left on this one without even a fraction still involved. It's just y minus 4.
I forgot to ask, on the one, on number 3, the one we did before,
Yep.
for our final answer, does it not have to be parentheses?
It doesn't matter. You can leave it in parentheses if you want, but they don't need to be. Parentheses are a grouping symbol, and there's nothing to group it to separate on that one still at that point, so that's why they become unnecessary. And that's actually the same thing on number 2 on the final answer that was on the farthest right, where I sort of ignored the parentheses and the times 1. Again, same thing. There's nothing that it needs to be multiplied by, so I don't have to include them. But if you did include them, it wouldn't hurt anything. Okay, so on number 5, again, we need a factor. right? They don't have any factors in them right now. You can't cancel term by term. That's not going to give you correct values. And let me actually just remind you why. I did it before back when we did fractions, but the reason why is it's something like this. Let's say you had 3 plus 4 and you had 5 plus 4. If I were able to just cancel like that, I would have something like this, and I would end up with 3 over 5, right? But if I were to simplify the top, I'd have 7, and the bottom I'd have 12. And 7 over 12 and 3 over 5 are not equal. Okay, so that's why I can't just cancel pieces at a time. I have to cancel the entire factors for this to actually work. Okay, no canceling pieces. So while it might be tempting to look at number 5 and say, hey, somehow like there's a 24 and there's a 32 at the end, somehow I can reduce those, you can't because it's not in factored form. Got to factor first. So the first the top part, do you guys want to do AC or do you want to do trial and error? AC. You guys mostly like AC. If you want to use trial and error, Bailey, you go right ahead. All right, so AC, this is 1 times negative 24. So I have negative 24. And the B value is 1. I'm sorry, it's 2. I looked at that wrong. I'm going to shift this up just a little bit. All right, so 6 and 4. So one of them is going to be 6.
6 is going to be positive, 4 negative.
Yes, 6 is positive, 4 is negative. And how do you know?
Because it's a positive 2.
Yeah, it's a positive 2 in the middle. So I'm going to change this expression on top, and I'll just do it within the problem, to say that it's y squared plus 6y minus 4y minus 24. Until I get it factored, there's no canceling. We'll just leave the denominator as it is right now, 2y squared minus 32. So we'll group the first two together, which is going to be pulling out a y. So y times y plus 6. Grouping the second two together pulls out a negative 4 to give me y plus 6. My denominator is, can I pull the 2 out of the denominator? You guys good with that? It has a common factor of 2. And then I'm going to have y squared minus 16. And then these two pieces are in common, so I'll pull my y plus 6 out in front. Sorry, I'm just checking on something else. Yes. And then y minus 4. The denominator is a 2. I've sort of been ignoring the denominator for now, but y squared minus 16 is a difference of squares. And it's actually the same difference of squares I had up here. So we've already looked at it once on the screen today. It's y plus 4 and y minus 4. So what reduces? The y minus 4 is reduced. We're leaving things in factored form. The numerator doesn't have anything except for y plus 6, so if you want to leave off the parentheses, that makes perfect sense. But we'll leave the 2 out in the denominator, and it's 2 times y plus 4.
Where did on the bottom, the 2y plus 1, 2, and then y minus 4, how did we get that?
Yeah, so we factored y squared minus 16.
Okay.
It's a difference of squares, and it's actually the same difference of squares I did in the previous problem, so I kind of jumped straight to it. Yeah. Yeah. There's not I only have a y minus 4 that matches on top of the bottom. The other ones both have y's in them, but they don't match. One's y plus 6 and there's y plus 4, so they won't simplify, unfortunately. Yeah. Okay, any questions on that one? All right. Number 6. Yeah, that was attractive. All right. Okay, so I know this looks like there's multiplication, and there is, but if you multiply this out, that is super counterproductive.
Yeah, I'm not going to.
All right? The whole goal in getting things to reduce and simplify is to factor them, right? So we do not want to actually distribute and multiply this out. Super, super unhelpful. But what we do want to do is to factor each of the pieces that we can. So you can kind of almost look at this and say, hey, it's already partially factored. It doesn't have that sort of look to it, but it is partially factored. So we're going to take one piece at a time. I'll start with the first, or the top numerator. The the top of the first fraction. 2x and 18, what do they have in common? A 2. So we're going to factor a 2 out of the first one, and I'm going to be left with what? X plus 9, yes. All right, the denominator here is just x plus 8. Do not cancel the x plus 8 and the x plus 9 and leave a 1 somewhere. That's not true. Okay? They're not like that. You'll notice I put the parentheses around the x plus 8. I didn't really have to do that. But I sort of want to remind you that in a minute here I am going to be multiplying all the pieces, but I'm not really going to multiply. I'm going to cancel based on where they are. How about the second numerator? Yeah, it's a 7. And what am I left with? X plus 8. Oh my goodness, did you see an x plus 8 somewhere before? Maybe so. All right, last piece is that final denominator. It has an 8 in it. And it's x plus 9, which you've also seen somewhere before. Like, these are contrived, right? Like, the whole goal is for you to recognize pieces they have in common. Like, that's what your expectation should be. Your expectation should be there's going to be some pieces that match. Really should. All right, so when we did multiplication of fractions with numbers, we talked about the fact that we could multiply across the top, multiply across the bottom, and then reduce. We also talked about the fact that we could reduce top and bottom or reduce along diagonals. Do you guys remember that? So you have a couple options. Let me show you one option. One option is to simply mush it all together, so to speak. I have 2. I have a 7. I'll put them just beside each other. I have an x plus 9, and I have an x plus 8. And then in the denominator, I have an 8. I usually put the coefficients in front. I have an x plus 8, and I have an x plus 9. Okay, so you can push it all together if it helps you to see it sort of all in one single fraction. But then you're doing exactly what we said, is that you're going to notice they have on top and bottom x plus 8. On top and bottom, they have x plus 9. All the x's actually ended up going away. Now, come back over to here. We could have just done it from here as well and not ever sort of pushed them together. I could have noticed that this diagonal had an x plus 8 and the other diagonal had an x plus 9. So you don't necessarily have to put them into a single fraction to see that. The one other piece that you should notice that they have in common is what? The 2. Yes, ma'am, the 2 and the 8. There's a 2 on the top, there's an 8 on the bottom. So I can divide each of them by 2, right? So this top divided by 2 will just cancel the 2 out. The bottom divided by 2 will give me what? 4. So I have a 7 on top and a 4 on bottom, and that is all that's left. There aren't any variables left on this particular one. Could have been, but there weren't. Okay, any questions on that one?
So whenever the house is 7 and 8, we have to find what they get divided by, and then that's it?
Yeah, you're looking for what they have in common that they could both be divided by. Yes, ma'am. And that's really what's happening with the variable pieces too. We just don't sort of feel like it sounds the same, but we are. I mean, when we're canceling out an x plus 8 on top and bottom, what we're really doing is we're dividing by x plus 8 on top, and we're dividing by x plus 8 on bottom, and we're getting a 1. So the same thing's happening with my variable pieces. All right, so I hope that at some point you feel like, hey, when she does her lessons, they sort of build from problem to problem on what we've just done, because that's exactly what 7 should look like. So now we're taking this idea of multiplication of 2 pieces, but each of the pieces themselves have some more factoring involved individually, right? So there is an x minus 3 on the top first fraction, right? That can't simplify any, but on the bottom, it can. So let's do, because you guys always tell me AC anyway, so we'll do the AC method on the bottom here. So I have negative 3 for the AC, and I have 2. Okay, so in order to kind of keep things clean, I'm going to just do all of the work for the factoring of that denominator right there, and then I'll put the factored piece in the equals part of it in a minute. So kind of like a scratch work piece for the AC method. If you do trial and error, you won't even have to have that piece. But what number would I need that multiplies to negative 3 and adds to 2? Negative 1 and positive 3. So x squared, negative 1, so negative x, and positive 3x, and negative 3. So we'll do the first 2 pieces. They have an x in them, which gives me x minus 1. What do the second two pieces have? A 3, which gives me x minus 1. So the x minus 1's in common with an x plus 3 left over. So over here, I know that I have x minus 3 on top, and on bottom, I now have x minus 1 and x plus 3. Okay, so that's my first fraction in factored form. Let's do the same thing now for my second fraction's numerator. AC is negative 2. And the B is 1. Two numbers that multiply to negative 2 and add to 1. Negative 1 and positive 2. So I have x squared minus x plus 2x minus 2. Kind of feels like the other one. Pull out an x, and I have x minus 1. Pull out a 2, and I have x minus 1. So there's an x minus 1 and an x plus 2. So my second fraction is x minus 1, x plus 2. Now, the second denominator. 3x minus 9, it's not a trinomial like the other ones were, but they do have something in common.
3.
A 3. Yeah. So we'll take out the 3, and what will we be left with? X minus 3. Okay, so I'm not going to do the step usually to mush them together. It's not something that I think is really necessary, but if you feel like it's necessary for you, please do it, okay? I'm just going to look across diagonals and top and bottom. So let's look across the first diagonal. X minus, like top to bottom, x minus 3 and x minus 3, those cancel. So these cancel out. And then we'll look across the other diagonal. This is x minus 1 and this is x minus 1, so those cancel out. So I've left with an x plus 2 here, an x plus 3 here, and a 3 here, and there's none of those that are going to simplify. So I'm left with x plus 2 on top. You don't necessarily have to put the coefficient first. I tend to. That's probably more standard notation is to put that 3 first and then put the x plus 3. But if you put it in the back, it would be okay. Any questions on that one? Okay. How is 8 different? It's division.
So can you just flip it and multiply?
Yes, indeed. So it's really not different. It's just different in the way it looks at the beginning. I'm still going to have to do some factoring and all that stuff, right? So let's just flip it first. You don't have to do that first, but at some point, I don't want you to forget to do it either. So we'll just do it first. 3x minus 9 times 9x minus 27 over 5. Okay, once I do that, it becomes just like the other problems I did. In fact, it's a pretty nice, clean one compared to the last couple of them that I did. The 8 and the 5, those individual pieces don't need any work to them, but the other two do. So 3x minus 9, what do they have in common? 3. So I pull out a 3 and I get x minus 3. 9x minus 27. Pull out a 9 and I get x minus 3. And I'm going to look across diagonals. Well, the x minus 3's cancel. There's actually something else that cancels too. The 3 and the 9 on the top of the second fraction and 3 on the bottom of the first one, are both divisible by 3. So I can divide by 3 here and by 3 here. So those cancel completely. I have an 8 on the top, I have a 1 on the bottom. I'll just write it out just to clean it up to make sure everybody's good. I have a 3 over here and a 5 over here. That's really what's remaining. And then it would be 24 over 5. So, yeah, Yeah, and Kayla, I'm glad you said that because I think it's probably worth saying out loud that when I talk about something being left in factored form, we're not talking about the numerical values left in factored form. We're talking about the parts with the variables being in factored form. This one didn't have any variables left, so it doesn't make any sense to leave it in a different fashion. We would multiply things clean through. Yes. Okay, number 9. It's our last one before you have a chance to practice some of your own. So, on number 9, what do I need to do, or what could I do first?
You could factor first or you can flip it.
Yeah, so you could factor first, or you could flip it first. Just be really careful that if you decide to factor first, you don't forget somewhere along the way that you were supposed to flip. So I'm going to flip mine first to make sure that I don't forget. In fact, I think I'll write it down underneath it. So I have x squared minus 3x plus 2 over x squared plus 5x plus 6. We always flip the second fraction times. Now it's 3x plus 6 over x minus 2. Okay, so there's some factoring that needs to happen. Let's start with this one right here. If I do the AC method, AC here is 2 and B is 3. So what do I have to do? Sorry, not 3, negative 3.
You need a negative 1 and a negative 2.
Okay, so I have x squared, and then what do I need?
Negative 1.
Yeah, I need a negative 1x and a negative 2x. And then I have my plus 2. And then on the first one, I pull out an x, and I'm left with x minus 1. On the second one, I have to pull out a negative 2, and I'm left with x minus 1. Pulling out negatives trips people up a lot of times, so be careful with that. So an x minus 1 is there, and an x minus 2 is there. So now I have x minus 1, x minus 2. That's the first piece. All right, we'll do the second piece, which is the denominator of the first fraction. So AC is 6, B is 5. Two and 3. Bailey's like signaling up here. It is 2 and 3. Positive, both of them, yeah. So x squared plus 2x plus 3x, or the other way around, of course, plus your 6. The first two have an x, leaving me with x plus 2. The second two have a 3, leaving me with x plus 2. So the x plus 2's match. Sorry, I'm really low on the screen, I know. And I'm left with x plus 3.
What is that? X squared plus 4x plus.
They came from the first denominator, right here, x squared minus 5x.
I know where you got it from, I just can't see it.
I'm sorry, say it again a little bit louder, Armani.
I know where you got it from, I just can't see it.
You can't see this?
Yeah.
Okay, so this says x squared plus 2x plus 3x plus 6.
Okay.
Okay. And eventually it factors down to x plus 2x plus 3. So over here now I have x plus 2, x plus 3. I haven't done any where the numerator and the denominator actually simplified well, since the very beginning of this lesson, but sometimes they will even within a problem like that. I might actually end up with pieces in top and bottom that cancel out as well, not just along diagonals, just FYI. All right, we have a denominator that is already in factored form x minus 2, but this numerator of the second fraction isn't. 3x plus 6. You can pull out a 3 and you're left with x plus 2.
That's almost like we just did that.
What's that?
It's almost like we just did that.
Did we just do that one?
Yeah, kind of.
Wow, we did. Oh, we did. Well, we did 3x minus 9. Is that the one you're talking about?
No, on the denominator of this problem.
Oh, yeah. It is almost like they matched on purpose, as is our expectation, right? It's so crazy. I know. If you don't see things canceling out, you probably have an error because that's not how the problems were created, right? They were created to cancel. All right, so we have across the top to bottom diagonal in the first one, we have an x minus 2 canceling. And then across the other diagonal, I have an x plus 2 canceling. So on the top, I'm left with a 3. Don't forget about that poor little 3 hanging out over there. X minus 1. And over x plus 3.
And we are finished.
And we are finished.
Then we start doing our homework.
Okay. All right, so pull out your homework and start taking a look at those.